Hi students, today we are going to discuss about the next point of current electricity. It is a meter bridge. It is a device, meter bridge, it is a device, electrical device used to determine the value of unknown resistance. It is based on the principle of Wheatstone's network. It is based on the principle of Wheatstone's network. Now let us see the construction of the meter bridge. It consists of a thin uniform wire AC. It is fixed in between two L-shaped plates on a wooden board. Meter bridge, it consists of a thin uniform wire AC of length 1 meter is fixed on a wooden board. This meter bridge, it consists of two L-shaped plates. See the shape. These are the two L-shaped plates, one metallic strip. These are the two L-shaped plates. This is the metallic strip. Metallic strip is placed in between two L-shaped plates in such a way that two gaps are formed. Metallic strip is placed in between two L-shaped plates in such a way that two gaps is formed. In one gap, a unknown resistor whose value is to be determined is connected. In one gap, a unknown resistance whose value is to be determined is connected, and in another gap a resistance box is connected. A battery of EMF E, plug key K, and rheostat RH, they are connected in series across the point A and C. Jockey is connected to point B through galvanometer. मीटर ब्रिज हा इलेक्ट्रिकल डिव्हाइस आहे की ज्याच्याकडे एक अतिशय थिन युनिफॉर्मचा अर्थ की ज्याचा एरिया ऑफ क्रॉस सेक्शन हा सगळीकडे सारखा असेल. डेन्सिटी म्हटल्यानंतर युनिफॉर्मलिटी आलीच. तर मीटर ब्रिज इट कन्सिस्ट ऑफ थिन युनिफॉर्म वायर ऑफ लेंथ 1 मीटर is fixed in between two L-shaped plates on a wooden board. And this is the construction of meter bridge. Now let us see that construction. Meter bridge is used to determine the unknown value of resistance and principle. It is based on the principle of Wheatstone's network principle. See this construction. Okay. Then after, the next point is working. Concentrate on the points of working. First one point, close the plug key K and take a suitable resistance capital R. Take a suitable resistance capital R from resistance box. Then touch the jockey on different points of the wire and find out the point D where the galvanometer shows zero deflection. The point D is called as balanced point. Now let us concentrate on the circuit diagram. This is the jockey. In working, first of all, take the suitable resistance from resistance box. Then you starts to touching the jockey at various points, and you obtain the point D at which galvanometer shows zero deflection. The point D at which galvanometer shows zero deflection, and when this galvanometer shows zero deflection, that point D is a balanced point. You measure the distance between point A and point D, and it is denoted by Lx. This length is exactly opposite to x, therefore it is Lx. And the remaining length on meter bridge wire, it is denoted by Lr. It is the distance between point D and point C. This length DC, it is denoted by Lr. And this is the length, balanced length opposite to resistance box, therefore it is denoted by Lr. Means length AD is equals to Lx and length DC is equals to Lr. D is a balanced point. In working, there is a concept of sigma, and it is nothing but resistance per net length. Sigma resistance per net length. Sigma is equal to total resistance of the wire divided by total length of the wire. Resistance per net length of the wire, it is denoted by sigma. See here, sigma into Lx. By putting the value of sigma, sigma is equal to R, capital R divided by capital L into Lx. This is the length, this also length. Length cancelled, therefore remaining term is a resistance and it acts as a resistance of Lx. In similar manner, sigma Lr is equal to capital R divided by capital L into Lr is equal to resistance of Lr. Sigma Lr, it is the resistance of Lr. See this point, let AD is equals to Lx and length DC is equals to Lr. Lx and Lr are measured on a scale. As the bridge is balanced, from Whetstone's principle we get x upon R is equals to resistance of Lx divided by resistance of Lr. X upon R is equal to resistance of Lx divided by resistance of Lr. X upon R is equal to sigma Lx divided by sigma Lr. Sigma is the resistance per net length. Here sigma get cancelled, therefore we got x upon R is equals to Lx upon Lr. Therefore x is equal to Lx upon Lr into R. By measuring Lx and Lr, and we know this is the value of resistance which is taken out from the resistance box. By knowing the value of resistance as well as Lx, Lr, we are able to determine the value of unknown resistance from this equation. This is the meter bridge. It consists of two L-shaped plates, one metallic strip. It is placed in between two L-shaped plates so as to two gaps is formed. It consists of a thin uniform wire having a uniform area of cross section. This is the suitable arrangement required for to determine the value of unknown resistance. This is the unknown resistance. This is the resistance box which acts as a variable resistance. Then after, this is the jockey, this is the galvanometer. By sliding the jockey on the wire AC, we are going to obtain the balanced point. Balanced point means the point at which galvanometer shows zero deflection. The next point of current electricity is Kelvin's method. It is a special method. It is useful for to determine the resistance of a given galvanometer with the help of meter bridge. A galvanometer whose resistance is to be determined is connected in the left gap of the meter bridge, and in right gap a resistance box is connected. Jockey is connected to point B directly. Then after, a battery of EMA P, plug key K, rheostat RH is connected in series across the wire, thin uniform wire whose length is 1 meter, that is the wire AC. A battery of EMA P, plug key K, rheostat RH, they are connected in a series across this meter bridge wire. Then before going to deal with the principle, we must know What do you mean of same deflection? Before touching the jockey to that meter bridge wire, you first of all close the plug key K, don't touch the jockey to the meter bridge wire, and note the reading shown by the galvanometer. For example, by taking the suitable resistance from resistance box, suppose the galvanometer needle indicates the reading phi on left hand side of the 0. You note this reading. Then after, if we touch the jockey now, then after if we touch the jockey at point A, then after if we touch the jockey at point C, the galvanometer needle must show the opposite sides deflection of phi. For that purpose, you adjust this rheostat RH. By properly adjusting this rheostat, that galvanometer needle must shows opposite side deflection. Start the part of working. By touching the jockey at various points on the meter bridge wire, you obtain the point D, at which galvanometer shows same deflection as adjusted before. See the point A, which is present at the left side of that meter bridge wire. Point C is present at the right side of meter bridge wire. Now let us consider this is the galvanometer. Whenever we will touch the jockey at point A, suppose that galvanometer needle is zero deflection. If we start to touching at various points on that meter bridge wire from point A, that needle starts to deflect towards phi. And at point D, that galvanometer shows, let us consider, at point D that galvanometer shows the deflection phi. Whenever that galvanometer needle shows same deflection as adjusted before, that point is a balanced point. Means here the point D at which the galvanometer needle shows same deflection as adjusted before. Then after, you measure the distance between point A and D. It is denoted by LG because it is the distance opposite side of the galvanometer, therefore it is denoted by LG. Here LR, it is the distance between point D and point C, opposites to the resistance box. This is the balanced distance opposite to the resistance box, it is denoted by LR. This is the meter bridge. There here the total length of that meter bridge wire, it is equal to 1 meter, means 100 centimeter. LG plus LR is equals to 100 centimeter. Therefore LR is equals to 100 minus LG centimeter. By noting all these points, now let us concentrate the further matter of working. Length AD, it is denoted by LG. Length DC, it is denoted by LR. Sigma, it is the resistance per unit length. We know that whenever the sigma is multiplied by LG, it represents the value of resistance of LG. When sigma is multiplied by LR, it gives the resistance of LR. Sigma LG, resistance of LG. Sigma LR, resistance of LR. By using Wheatstone's network principle, we get G upon R is equals to resistance of LG divided by resistance of LR. Sigma LG divided by sigma LR. Now once again see the diagram. G divided by R, Wheatstone's principle, Wheatstone's network principle. G upon R is equal to resistance of LG divided by resistance of LR. G divided by R is equal to resistance of LG divided by resistance of LR. Here G divided by R is equals to sigma Lg divided by sigma Lr. This term gives the value of resistance of Lg, this term gives the value of resistance of Lr, sigma get cancelled, therefore G divided by R is equal to Lg upon Lr. By transferring this resistance to RHS, we got capital G is equals to R into bracket Lg upon Lr, but Lr is equals to 100 minus Lg, means G is equals to R into bracket Lg divided by 100 minus Lg. By measuring Lg and by knowing capital R, with the help of this formula we are able to determine the resistance of a given gallanometer. जर आपल्याला रेजिस्टन्सची व्हॅल्यू माहीत असेल, आपण एल जी व्यवस्थित मेजर केला, या फॉर्म्युल्याचा यूज करून आपण गॅलॉनोमीटरची व्हॅल्यू इझिली डिटरमाइन करू शकतो. बाय यूजिंग दिस फॉर्म्युला वी आर एबल टू डिटरमाइन द व्हॅल्यू ऑफ the resistance of a galvanometer, and this is the Kelvin's method. Thank you.